Okay, so we'll get started. Thank you all for joining us for the last webinar of the spring webinar series for the Northern Grapes Project. We've had some great talks this spring, and I'm excited to start this one with Demi Perry, which is going to be very interesting. I know it's very applicable to all of our practical winery needs. So my name is Raquel Callis. I'm the Extension Support Specialist for the New York Statewide Viticulture Extension Program. Our speaker today is Demi Perry. She's a technician in Anna Catherine Mansfield's Enology Lab, and she's also a PhD student in Gavin Sachs' lab. Demi received her undergraduate degree in chemistry from Cornell, followed by a master's in food science at Penn State. She worked at Heart and Hands Winery on Cayuga Lake before returning to Cornell to take up her current position. Her research expertise is in understanding the sensory perception and chemistry of foxy aromas in native grape varieties, and she is working towards a process to remove them to create more neutral wines and juice. So with that, I'm going to hand it over to Demi. Thanks, Demi.
Okay, let me just try to share the screen here. Okay, can everyone see the presentation? The Cornell Cals logo should be up.
You're great. Yep. Perfect.
Okay. So the topic of today's talk is going to be SO2 and you, understanding the when, why, and how of SO2 management in your winery. So I was seeing a lot of people are either winemakers or assistant winemakers that have probably been doing this for a while, but I've also been seeing some home winemakers who are maybe looking to jump into a small scale and try to go pro, so to speak. So this is really going to be kind of the in and out of sulfur dioxide management, kind of why it's important to manage. And I'm not going to tell you if you should add it or if you shouldn't. That is more of a personal choice. It depends on your style. But I'm going to tell you kind of the science behind it and why it's been used for hundreds of years in winemaking. So let's start with a couple wine myths. So is and is not. So a claim that I received and that you commonly read a lot is, I get headaches from drinking wine, so I know I am sensitive to sulfur. And maybe that explains why I am allergic to eggs. Okay, so there's a lot going on here, but if we pick this apart, it all comes down to what do we mean when we talk about sulfur? So if we talk about sulfur in its purest form, it's an element, right? So if we look on the periodic table of elements, sulfur, just like carbon, just like nitrogen, it's an element. And these are found in many protein-rich food sources. So things like eggs, meat, you're going to have a lot of amino acids like cysteine and methionine, and they're going to be your sulfur-containing amino acids that are really going to be making up those protein chains and leading to sulfur consumption, which is good for your health. You also get sulfur through some leafy greens and cruciferous vegetables in the form of MSM, right? So when we talk about sulfur, we are ingesting it on a regular basis, but today what we're going to talk about is more sulfur dioxide, specifically in the form of sulfite. So what is sulfite? So you can see there that we have one sulfur bound to 3 oxygen atoms. And that 2- just indicates that it's going to be an ion. So a sulfite is a sulfur-containing molecule, and often this is found in things like dried fruit. So it's been used for years as a preservative, processed foods, and naturally found in alcoholic beverages like wine. So I just said it's naturally found. So this leads us into our next claim. So I haven't added any external sources of sulfur to my wine, so I can therefore label my wine as sulfite-free. And again, there's a lot going on to this claim as well. Perhaps you can't do that, and why? So yeast will naturally produce sulfur, specifically sulfur dioxide, as a result of part of its metabolic pathway. So this sulfate reduction pathway that yeast goes through is going to naturally produce 0 to 20 milligrams per liter of total sulfur dioxide. and this is referred to as a low SO2 producer. So commercial yeast like Saccharomyces cerevisiae and Ellipsoideus, these are considered low sulfur dioxide producers. However, there are certain strains. So if we think about strains like Saccharomyces bayanus, these are going to be considered high sulfur dioxide producers, and these can generally and consistently produce up to 80 milligrams per liter of total sulfur dioxide. Now, in the United States, if you wanted to label your wine as sulfite-free, or if you wanted to file a waiver with the TTB to try and be excluded from your sulfite or contains sulfite label, you would have to be below 10 ppm or 10 milligrams per liter of total SO2. So chances are, if you have a high SO2 producer yeast, you're not going to be able to escape that contains sulfite label. Now, interestingly, let's say you use Saccharomyces cerevisiae, right? So there was a study done back in 2009 that took a low SO2 producing yeast strain and used it to ferment a bunch of different wines. So we can see here Riesling, Pinot Blanc, Chardonnay, and across different vintages as well. So this is supposedly a low SO2 producing yeast strain, and yet we can see that there is significant variation from year to year and grape to grape based on how much total SO2 is resulting as a product of this metabolic pathway. So we can see that, yes, in some instances it is low SO2 producing, but we can also see that in other instances it's going to be a little bit higher. So this to say, not all sulfites that are in wine have been added. Okay, so why add sulfur dioxide? So sulfur dioxide is going to serve a lot of different functions. It's going to act antimicrobial. It's going to be antioxidasic. So this is not antioxidative, this is asic, right? So we're talking about disabling enzyme activity here. And specifically PPO or polyphenol oxidase, right? So we have an example here of a bitten apple, right? So PPO is the enzyme responsible for that browning, and it's also going to be the enzyme responsible for white must browning as well. And there in our little cartoon on the right, we have an officer. So he's going to be binding acetaldehyde on the top. And for those of you who are familiar with acetaldehyde, I'm sorry, but it is inevitable sometimes that you get that. And so what that is, we're all familiar with it, probably that nutty, bruised apple smell. It's just not something that's desirable in your wine, and it's also something that is toxic and pretty low concentrations actually. So we're going to add some SO2 to bind some of that up. And at the same time, it's also going to scavenge hydrogen peroxide. And now hydrogen peroxide on itself is more or less harmless, but this is going to prevent radical reactions from occurring that would otherwise form as a result of catalysis. And so these would be things like undesirable esters as well as undesirable aldehydes. So there are many forms of sulfur dioxide. The equation that we have at the top there, I don't want to be too chemistry specific for people out there that see chemistry and get kind of scared. But sulfur dioxide really is all about the chemistry of wine. So if we add sulfur dioxide to water, we see that it can dissociate into a proton, so an H+, as well as a bisulfite. So now what do I mean by bisulfite? That's going to be your HSO3 minus. And now this can dissociate further into two protons. So if you knock a proton off the bisulfite ion, we're left with just the sulfite ion, and that's going to be our SO3 2 minus. So being the chemistry geek that I am, I would like to point out that when we see labels that say contain sulfites, it actually contains bisulfites. And now why is that? So if we look at the graph here, this graph is basically telling us that there is a strong pH dependence that's going to influence the equilibrium, or that is to say the dissociation of sulfur dioxide into these different forms. So we see that at wine pH, so typically between 2.5 and 3.5, we're mostly in the bisulfite form, but we also have a significant portion of sulfur dioxide that is going to be contributing to our solution as well. So we can see that the sulfite ion, so the SO3 minus, that really is not going to be present in any significant or considerable amounts. So this is important going forward because a lot of people use sulfur, sulfite, sulfur dioxide interchangeably, and that is confusing, especially if you're trying to do calculations to figure out how much sulfur you actually have and need in your wine. So what do we mean when we talk about sulfur, right? So we just looked and we saw that molecular sulfur dioxide, that is to say the sulfur dioxide when it's in solution with water, that is going to be what we call molecular sulfur dioxide, right? So there's going to be some at wine pH, but overwhelming, we're going to be looking at bisulfite, so the HSO3 minus, and this is going to make up our free SO2. So our molecular SO2 plus our bisulfite is going to be what we call free SO2. And now this we'll get into, but this is really your most important measure because it's the free SO2 that's going to be able to have those antioxidative properties. On the flip side, we have our bound SO2. So this is SO2 that has been bound to other compounds like sugar, phenolics, as well as acetaldehydes. So you've added some sulfur into solution, and now it's either been bound to acetaldehyde, which it prefers to bind to, but there's also other things in there like sugar, some anthocyanins that SO2 can bind to as well. So when we're looking at the big picture, we're looking at total SO2, right? This incorporates free SO2 and bound SO2. But keep in mind that all of these terms mean something very different. So like I mentioned, your buffer zone against oxidation is really going to be your free SO2, and your molecular SO2 is going to be your most effective antimicrobial agent. So this is really important to consider going forward. Your molecular SO2 is also going to be that which is volatile. So any SO2 that you're smelling from your solution, or if you add things to wine, that's going to be the odorous component. And like I said, the bound SO2 essentially has already done its job. It is not free to act or bind any more compounds in the wine. So how is sulfur added to wine? I've mentioned that you're adding things, but what exactly are you adding? What exactly do I mean by sulfur? So in most cases, we're going to be adding sulfur in the form of KMBS, also known as PMBS, more commonly known as potassium metabisulfite. So potassium metabisulfite is a white powder, as you can see there, and it is commonly dissolved in warm water. I will say that this warm water should be as pure as possible, so I recommend using distilled water to make up your sulfur additions. If you have impure water, especially if you're on city water and it's not so clean, it can have a lot of dissolved oxygen that can react with the KMBS before you can even add it to the wine. So by using distilled water, you can really make sure that the KMBS that you're adding to your wine is making it to your wine and not actually being consumed by the water itself before you add it to your wine, or must. So we're taking our KMBS, and what is this 57% that I have here? So anyone who's made a KMBS addition before knows that not all of the mass is going to be available as SO2, only 57.6%. This is based on the molecular weights of the atoms or in the elements in the molecule itself. So only 57% is going to be available as sulfur dioxide. So after you do some math, I didn't show all the conversions here. They're not important, but the volume of wine in gallons, sorry to our Canadian contingent, which uses liters, your volume of wine times your desired SO2 addition in ppm or milligrams per liter times a conversion rate, so 0.0066, is going to give you the mass in grams of KMBS needed to add to wine. So that equation is something that you probably all know, or this is also the equation behind all of the online calculators that do the math for you. So how else is sulfur added to wine, or is it? Is there another way? So some people use liquid sulfur dioxide solution, and this is made from bubbling gaseous sulfur dioxide into the water. There are quite a few drawbacks associated with this, really the number one being it's dangerous. So there's a considerable safety risk imposed here. SO2 is volatile, it's dangerous to inhale. It's really not something that you would want to breathe in. So I haven't personally seen this used at any wineries, but I have been told that there are some that do this. Some of you may say, well, let's use sodium metabisulfite. There's a 67% instead of 57% conversion into functional SO2. Unfortunately, there are health implications for sodium intake, so this is more often used as a sanitizing agent, if at all. Some of you, I have seen this used at many places in the Finger Lakes as well as some other small wineries. You clean your barrels with elemental sulfur tablets. So this is an effective way to clean barrels. Normally there's a period of time that you let these kind of breathe and air out before you actually add wine to them. You have to be very careful not to leave unburned sulfur or ashes behind. Now, why is this? Well, if you leave it behind, it's going to form hydrogen sulfide, which doesn't have that burning SO2 smell. However, it does have a rotten egg smell. So I guess, take your bets with what you want to leave behind. But in theory, you really don't want to leave any sulfur behind in your barrel. So this can contribute up to 10 ppm total SO2 for a 225 liter barrel. So if you're putting red wine or white wine in a standard size barrel, you can expect that you might get some residual SO2 contribution from the act of sulfuring your barrels. So at this point, you might say more is better. Just go ahead and dump in the SO2 because it is antioxidant, it's antimicrobial. So it's great. Just dump as much in as you want. So please don't do that. And please don't tell anyone that I told you to do that. What is this going to lead to? So this is going to lead to sneezing and burning. So there is an unpleasant aroma, so a struck match aroma that you will get if you have too much sulfur dioxide, and it will also burn. So there is a trigeminal sensation that is associated with sulfur dioxide as well. So in addition to smelling bad, it will also just hurt, and it may cause unpleasant sensations to occur as well. It can also lead to bleaching. So I did have a question that I received ahead of time about how sulfur dioxide can affect color and if it can lead to color loss. And there's a very complicated answer to that, but short answer is if you add copious amounts of SO2 to a finished red wine, you're essentially just going to be bleaching all of those colorful anthocyanins. So that is another bad side effect of adding too much SO2. On the flip side, if you add too little, right, obviously you can get oxidation, so microbial spoilage, acetaldehyde production, oxidative browning. So you kind of just want to go for that Goldilocks sweet spot, right? So you need it just right. And of course, there is a legal limitation. So in the US, you're only allowed up to 350 ppm total SO2. So remember that your total SO2 is going to be a contribution of your yeast and also anything that you add as well. Canada, our neighbors to the north, they're about the same regulations, so 350 of total SO2, and they have additional limitations on your free SO2. Australia, so they specify, in addition to the EU, they specify really based on residual sugar. So in a moment, I'll get to why that matters, but essentially, the more sugar that you have, recall that some of your bound SO2 can be to sugars. So they allow for a little bit more total SO2 if you're selling a sweeter product, such as Sauterne, some of your ice wines, you know, some of the sweet dessert style wines of the world, essentially. And again, in the EU, right, they further break it down to white, red, with different requirements for both. Red wine being a little bit more protected from oxidation due to its phenol content. Well, you might say, okay, well, let's just dump in a whole bunch of SO2 and then whatever we don't need at the end, we'll just try to get rid of. This is not a good approach. Some people claim that they can blow off some of the sulfur dioxide by bubbling with nitrogen gas. I would not recommend this, as you're also going to be volatilizing all of those beautiful and desirable fruity esters and all those desirable compounds that you actually want that make up the bouquet of the wine. So I would advise against that. I would also advise against adding hydrogen peroxide. Some of you may be thinking, well, if KMBS, right, if that sulfur binds to hydrogen peroxide, I will just dump a bunch in and then it will precipitate out with sulfur, form some sulfuric acid, go into solution and not be a problem anymore. This is a problem because this is illegal in many parts of the world. So I would not advise that approach either. So the best advice I can give you is the most obvious advice, right? Don't add too much SO2 to begin with. And know your pH, right? So I alluded to the fact that there is a relationship between molecular SO2 and free SO2 before. I knew some of you wanted numbers and equations, so here it is. Your concentration of molecular SO2 is going to be equal to the concentration of your free SO2 over 1 plus 10 to the pH minus 1.81. And essentially this is using the fact that there is this relationship between the pH, it's using the pKa values. So in other words, how acidic does it need to be to dissociate into the bisulfite ion? But essentially, if you have this equation, that's as far as we need to go in terms of the chemistry. And if you don't like equations, here is a more visual representation. So our 0.6 milligrams per liter molecular SO2 target and our 0.8 milligrams per liter, remember that milligrams per liter we're using interchangeably with ppm of molecular SO2. So we can see that these two lines here represent the amount of free SO2 required to end up with either 0.6 or 0.8 ppm of molecular SO2. And now how am I getting these numbers? Why 0.6, why 0.8? Remember that this is going to be useful for antimicrobial activity. So because it's not as much fun to just talk at you as it is to actually make you think, I have a practice problem. So a white wine with pH 3.2 is soon to be bottled. How much free SO2 is required for a molecular SO2 concentration of 0.8 ppm? So I will pause for just a moment while you think about this. Okay, I'm sure everyone has the answer in their head. Now, 20 ppm, hopefully that's what you all got. So a white wine with pH 3.2, so we can look and locate our 3.2 pH on our graph. We can trace up to the 0.8 ppm line and look over for the free SO2 required, and we see that approximately 20 ppm of free SO2 is required. Hopefully you all got that. If not, there will be a moment for questions in just a bit. Practice problem 2. A dry red wine with pH 3.6 is soon to be bottled. How much free SO2 is required for molecular SO2 of 0.5 ppm. Now at this point you may be thinking, uh-oh, 0.5 ppm. That's not a line on the graph. Remember, you do have an equation I gave you. I know that some of you may not have a calculator handy, so let me do the math for you. Now our molecular SO2, our concentration is 0.5. That's our desired concentration. We're going to go ahead and solve for x, and we get that our free SO2 concentration needed for a 0.5 ppm molecular SO2 concentration is 31.3 ppm. Now, at this point, I will take questions this far into the presentation. I think, Raquel, you're going to help me with that.
Yeah, so, okay, we've got one already, and everybody feel free to put them in the Q&A. Sean said, are there options for organic producers besides the dangerous liquid SO2 additions?
Ooh, okay. All right, so organic. If I recall correctly, and I can only speak for the United States here, but in order to be organic, I believe you are allowed to use yeast that produce higher sulfite wines. I believe you are not allowed to add any external sources of sulfur. I'm not exactly sure on that. I think you need to not only use organically farmed grapes, but you also, I don't believe you're allowed to use any external sources of sulfur. Some people try to get around this by just putting on the label that they use, that the wine was produced from organically grown grapes, instead of having the entire wine labeled as organic.
Okay, great. Let us know if that answered it, Sean. Tony wants to know why a winemaker would choose 0.6 molecular over 0.8 molecular.
Yep, so that is something that I will get to shortly. But essentially, it's going to depend on, is there a high level of residual sugar in your wine? Is it a red? Is it a white? As well as if it's going to undergo MLF or if it already has undergone MLF. But yes, I will get to that specifically in just a moment.
Great. Okay, sit tight on that, Tony. So Michael wants to know, should you account for any potentially lost free SO2 during bottling operations?
Yes, and I will go step by step through the production process following. I just wanted to make sure that we're clear on the terminology and the chemistry before we dive into add it here, add it here, add it here.
Okay, cool. Then maybe you might address these two, but let's just get them out of the way quickly. Is there any downside to dissolving KMBS powder in wine rather than water when making an addition?
So there is a chance that if you were to dissolve KMBS in wine before adding it to, so are we aliquoting some wine out and then adding it back into the larger volume, or are we just putting the powder into the large volume of wine?
Yeah, Dustin, oh, he said yes, so I think that was yes to aliquoting.
Okay,
Yeah.
so if we're gonna assume that he's aliquoted some wine out, so if you were to do that, in theory, as long as you can make sure that it's fully dissolved in the wine, and then you were to add it to the large volume of wine fairly quickly, I think that would work okay. There is some solubility issues if you need to add quite a bit of KMBS. So that's why you not only need to add to water, but you need to add it to warmed water. I assume that you probably wouldn't want to be warming up your wine before you add KMBS to it in order to get all of it to dissolve. But if you're just doing a small amount and you're adding it pretty quickly, you know, I guess I can see that it might not make a huge difference, but don't quote me on that.
Okay, and Arlen wants to know about adding it directly to a large batch.
I would not recommend doing that. What's going to happen is it's probably all going to settle to the bottom, and it's not going to be distributed evenly. I don't know about you guys, but when I worked in a cellar, we had a giant container of KMBS, and sometimes we would just get giant clumps of it. And those clumps, they take some effort to break up sometimes. So if you just dump it in a vat of wine, the clump is just going to sink right to the bottom, and just sit there. And it's not going to be particularly effective at dissociating or helping with your wine.
Yeah, I used to notice that as well. Clumps are annoying and they're not good to leave around.
No.
So David wants to know, when mixing an addition of KMBS with distilled water, there is usually dissolved air in the water. Should we pre-boil the distilled water first?
Wow, that's going above and beyond.
That's
Um,
technical.
yeah, I mean, there would be no downside to that. And I think that that can only help, right? Because if you were to do that, you would essentially be sparging and removing most of the dissolved oxygen from the water. I don't think it has a severe effect if you don't do that. But if it's a cold winter day, go ahead and get out the hot plate and boil it. I would advise, if you do that, do not add the KMBS while you're boiling, because you're just going to volatilize the sulfur, and that's your respiratory system is not going to thank you for that one.
Yeah. Okay, great. We'll do one more. So Madeline just wants to know if you're going to review how to measure residual free SO2 before making additions.
Yes.
Okay, great. So we'll leave that for later. And then Tim has a question, but we'll leave that one for the end. So
Okay.
let's let you get back to it.
Okay. So this table essentially has done all the math for you from the previous equation and from the previous graph. So if you know your wine pH, so if I haven't stressed enough at this point, know your wine pH. Measure it once, measure it twice. Be sure that you know where your wine is, because that is going to have a direct impact on your sulfur dioxide content. Now, I said before, how are we picking these numbers? Why 0.6, why 0.5, why 0.8? Are these just arbitrary numbers? No, they are not. So Saccharomyces cerevisiae is inhibited at 0.8 ppm molecular SO2. So if you're adding if you're adding SO2 to inhibit some wild fermentations with your must, that's where that 0.8 ppm is coming from. If you're arresting your fermentation so that there's some residual sugar by adding sulfur dioxide, that's where that number is coming from. So that 0.8 ppm is really just the inhibitory level for Saccharomyces cerevisiae. Bacteria, wild yeast, things like Brettanomyces, these are inhibited at an even lower level. So these are inhibited generally at 0.4 ppm of molecular SO2. But our general recommendation for molecular SO2 is 0.8 ppm for whites and 0.5 ppm for reds. And again, why this difference? Reds have other inherent protective agents in them. Mainly they're phenolic compounds, so we don't need quite as much oxidation protection from added sulfur dioxide. Whereas whites, they don't have this protection, and they're also more susceptible to things like microbial spoilage, especially if they have measurable amounts of residual sugar. We saw before that the regulations were above 3.5 grams per liter. So just keep in mind that if you're bottling something sweet, whether it is a sweet Riesling or a late harvest, you're typically going to want to shoot for a higher concentration of molecular SO2. Okay, so let's walk through. We've got our terminology straight. We know what sulfites are. We know what bisulfites are. We know their dependence on pH, but how does this actually translate to adding to the wine or the juice, and when? So this is kind of the overall flow of your production, right? So we bring in the grapes, we've harvested them, And we're considering this a pre-fermentation stage. So we can maybe add some KMBS here, and I will go into what that maybe depends on in just a moment. Fermentation, for reasons that I just explained, hopefully you know that you don't want to douse your juice with KMBS right before you try to inoculate it. Your yeast will die and your fermentation will not happen. Post-fermentation, you are likely making an addition there, and then during storage and or pre-bottling, that is really your last chance to make any sulfur additions that you would like before you actually bottle and eventually sell your wine. So harvest and pre-fermentation. So why did I say that SO2 is maybe added here? There are a lot of factors to consider. So how clean is your fruit? So if your fruit is really clean and you don't have a lot of spoilage organisms creeping on your grapes, there's less of a need for sulfur to be added at this point, unless you want to prevent any spontaneous or wild fermentations. So there has been a trend in trying to inoculate using native yeast. So if you were to try to do this, right, you have to keep in mind that if you want to add some sulfur so that maybe you can protect it a little bit, you don't want to add too much if you want those native yeast to actually be able to ferment the juice down the line, because they will die and then you'll have to inoculate. Do you want to prevent oxidative browning? So we can see there on the bottom right. So our left juice was treated with sulfur dioxide, our right juice was not. And you can see that the right juice clearly shows browning. And again, this is due to PPO, so polyphenol oxidase. And it's important to note that this browning does go away during fermentation. So there's been a little bit of a debate every decade or so about whether it's better to intentionally brown the must, because it leads to more protective effects down the line. And while that's a discussion in itself, that is something to consider. And also, do you want to prevent MLF? So if you're doing a Chardonnay down the line, you might have to think about how much sulfur is too much sulfur, because at high levels of molecular SO2, you can start to inhibit some of the malolactic bacteria. So as a general rule of thumb, 30 to 50 ppm is advised after crush for whites, and 25 to 50 ppm is advised after crush for reds. So we've gone through our harvest and pre-fermentation, we've gone through our fermentation now, and now it's time for the post-fermentation. So factors to consider here. So we now have wine. This is no longer juice, this is no longer must, we have a finished wine. So is the wine going to undergo MLF? So is it a red that you want to put through MLF? Is it a white that you want to have more of a buttery mouthfeel? Do you want it to undergo MLF, right? Or are you intending it to? Whites, generally you want to prevent microbial issues and oxidation browning at this point. So if you intentionally browned your juice, that is okay to some extent, right? Because it goes away during fermentation. But now that you have a finished wine, you do not want that browning. Reds, so there's less oxidation protection here. So there's more oxidation protection already in the red wine inherently. So less additional oxidation protection is generally needed from sulfur. I did have a question ahead of time that asked about aging things sur lie and if that has anything to do with added sulfur. So generally, if you're aging your wine on the lees, there is some protective effect from oxidation that is contributed by the yeast. The exact extent to which they protect from oxidation has not really been classified very well. But from kind of talking with people and from trade journals, it seems that there is some minor protective effect by leaving things on the lees. So you might not have to add quite as much sulfur if you're doing that. The general rule of thumb here, we start to see now that we have a finished wine, we're really gunning on this 0.8 ppm molecular SO2 for whites and 0.5 ppm molecular SO2 for reds, because at this point, what we're concerned is with microbial spoilage. So we've gone through harvest, fermentation, post-fermentation, and now we're at the pre-bottling stage. This is our last chance to add sulfur to the wine. So essentially what it's going to come down to is how much oxidation have we afforded ourselves with added sulfur, and what is our cap enclosure. So again, does our wine have significant residual sugar? If so, you're going to be leaning towards a higher end of added sulfur. What kind of bottle enclosure are you using? I'll show you a figure in just a moment about how that's going to affect SO2 over time. How long is this going to be in the bottle before release? If you're planning an immediate release, if it's a white or a rosé that you know is going to fly off the shelf, you know, maybe you're going to use a lower dose, not only because it's going to be consumed quicker, but also because, you know, if you open it a month later after adding a high addition of sulfur, it's going to burn, it's going to smell bad. You're not going to have given the sulfur enough time to actually scavenge oxygen and those different oxidative agents. So that is something to take into consideration as well. The final pH of the wine, again, I can't emphasize enough how important pH is. And then how much oxygen exposure will the wine have during bottling? So bottling lines really vary. You know, if you're hand bottling, so if you're just pouring your wine into a big bucket and then siphoning, right, there's going to be a lot of oxygen exposure there. Or do you have, you know, a fancy bottling line where you're doing it under pressure or, you know, under inert gases? You know, are you filtering beforehand? All of these different considerations are going to have to be made when thinking about how much oxygen is going to be essentially put into the wine during the bottling process, because after you bottle, you know, if there's more dissolved oxygen than you are anticipating in that wine as a result of bottling, there's really not a way to correct for that. So that's definitely something to consider when you're thinking about what your final SO2 addition is going to be pre-bottling. But another rule of thumb here, free SO2 levels pre-bottling. So obviously first you want to measure to figure out what the free SO2 is to begin with, but add enough for about 30 ppm of free SO2. And why 30 ppm? This should carry you through the aging process in the bottle. So I alluded before to the fact that different enclosures are going to have an effect. So there was a study done back in 2001 that looked at a whole range of enclosures, so synthetic corks and technical corks and natural corks, as well as screw caps. But I'm guessing that most of you either use natural cork or screw cap to some extent. So we can see that the natural corks, so they start around 30 ppm of free SO2, and after a year or so, they've been reduced to about half of that concentration of free SO2. We can see for the screw cap, so that's going to be, you know, significantly less. So only a third of the free SO2 has been lost, so about 67% remains after a year. So it really just depends on how quickly you're releasing it, how long you intend to hold on to it, and again, you know, what do you want the oxygen ingress rate to be? All of these are considerations to take into account. And I will note here that this particular wine studied in this enclosure had a pH of 3.1. It was 11% alcohol, and it was very, very dry. So again, things to consider when you're thinking about how much sulfur to add pre-bottling. So there was a question about how do we actually know how much free SO2 is in our wine? And this comes down to different methods for analysis. So there's a lot of chemistry involved here, so I'm going to try to keep it simplified. But we have what's called the Ripper method. So in the Ripper method, essentially what we have is a titration with iodine. So iodine is going to bind those sulfites. So we call that a lot of your free SO2 is going to be made with HSO3 minus, so that's our sulfite. So iodine is going to bind with those. And when there's no more sulfite left in the wine for iodine to bind, it's going to start binding with some starch complexes. And so those starch complexes are going to be what you see as color. So when you get that color change, it means that all of your sulfites have been bound by the iodine, and essentially you have no more free SO2 in your wine. And the problem with this, as is the problem with any titration that relies on color changes, is it's really objective, right? So as long as you do it consistently, I would say that it's probably good enough, but it is something to take into consideration. Titrettes, so these are essentially portable, handheld. That's the picture on the top right there. Essentially, it's an encapsulated Ripper method that has iodine titrant with acid solution and color indicated inside. So the way that this works is you add enough wine until the liquid starts to lose its color. So it starts as a colored solution. You add enough wine so that you're adding sulfites to actually bind with the iodine and turn the solution from colored, so kind of like a blackish, purplish, to a colorless solution. And then we have aeration oxidation methods, commonly referred to as AO. This is really a benchtop chemistry setup. So there's a lot of glassware involved with this unit, but essentially what you're doing here is you're measuring free SO2 by blowing off volatile SO2 with air, and you're trapping this volatile sulfur dioxide with hydrogen peroxide solution that also has a color indicator. So what this does is, recall earlier I said, well, you can just bubble sulfur dioxide out, right, and react it with hydrogen peroxide. What does this form? Sulfuric acid. What can you do? You can titrate. So again, another titration, but this time there's a step ahead, right? So you're bubbling, you're volatilizing that sulfur dioxide before you can actually convert it to sulfuric acid, and then you have to titrate that with sodium hydroxide. So there's quite a few steps involved with that one. You can do free SO2 and bound SO2. Bound SO2 is measured in a similar way, but you actually boil your wine so that you can volatilize the bound species. So that essentially is AO. And then on the bottom there, we have that fancy looking instrument that's called a FOSS, Theostar. That is segmented flow analysis. I won't go into too many details there, but essentially what's happening is that you're reacting with a reagent, and this is going to form a yellow dye. And then this yellow dye is actually read photometrically. So this is a very accurate method, but each of those units pictured there, so there are actually two units pictured, one on the top, one on the bottom. One measures free, one measures bound. Each unit is $15,000. So if you are a huge operation making many SO2 measurements on a daily basis, this might be a good option for you. If you are a small winery with, let's say, only 10 different lots of wine at any given moment, this is probably not a great investment on your part. So comparing the three methods with excluding the segmented flow analysis, we have the Ripper method, the titrettes, and the AO, right? So there are pros and cons to both. You know, the Ripper and the titrettes, they're really quick. They're easy. There's not really a lot of risk associated with any of them. They're pretty portable, right? So you can carry them around the cellar or the barrel room and get a measurement pretty easily. The main con is really they're not hugely accurate. I think for the purposes of, you know, of what you're trying to do, it's probably not going to make a huge difference. But you know, if especially at low free SO2 readings, it's going to be an inaccurate method. So you know, something to consider again when you're figuring out, oh, okay, well, should I invest in a ripper setup, or should I get some titrates, or should I just send this out to a lab? And again, the AO, right? So it's very accurate and precise. I didn't show the setup here, but there's a lot of glassware involved. There is a time-intensive distillation step where you're waiting for all the SO2 to volatilize and you're bubbling air up through it. And then you have to do an additional titration step beyond that. So again, a lot to consider here and figuring out which SO2 method of analysis you actually want to use. So some calculation resources. I gave you a table before when you were trying to decide, I have a wine with this pH and I'm going for this molecular SO2 concentration. So if you're trying to figure out exactly how much KMBS you need to add, if you go to vinoenology.com, specifically the SO2 addition, there are a number of different calculators to help you in your calculations. So in addition to telling you how much KMBS you add, you can also calculate or put in, how much of molecular SO2 you want, what your pH is, how much free SO2 you want. And so there's a lot of different options on there to help you with your calculations so that you don't actually have to get out your pencil and paper every time and do all the equations yourself. There's a lot of different content resources. So the studies that I referred to today are listed here. And again, these slides will be made available to you. Sites like Cornell Extension, we have a bunch of different resources to help you as well. If you remember anything about this talk, right? So boils down to, let's say, these 5 points. So molecular SO2, remember that is the SO2 component that's dissolved in water, right? And remember that it's going to be between 10 and 15% roughly at wine pH. So this molecular SO2 concentration, you want to aim between 0.5 and 0.8 ppm for that antimicrobial effect. Free SO2 is pH dependent, but we want to aim generally for 20 to 40 ppm additions either during crush and harvest and or post-fermentation and or storage. And I say and or, why is that? Remember that SO2, it's being bound. It's in dynamic equilibrium, right? It's if you dump it in at 20 ppm and measure it a month later, it's not going to be 20 ppm still. So it is a consumable. So you definitely need to measure throughout this process, and you cannot necessarily assume that the addition that you're making is going to lead to a direct calculation, of free SO2. Because remember that there are other things in your wine that are going to bind some of those SO2 components. Our wine style, right? So things like sugar, that will affect your free to bound SO2 ratio. And remember, only the free SO2 is available to help you as an antioxidant, right? So anything that gets bound, right? Maybe the bound SO2, it did its job in terms of helping you reduce acetaldehyde in your wine. But again, some of those bound SO2, they might be with other dissolved soluble solids, right? That aren't necessarily oxidative products. So it's not always going to selectively bind what you want it to. So know your wine, know your pH, measure those free SO2 levels, and then aim to get your SO2 levels just right. So too much or too little can lead to serious wine defects, right? So we talked about too much is going to strip color and lead to undesirable off aromas, right? And too little, I'm not going to sit here and tell you that you have to add sulfur to your wine. Otherwise, it's going to be bad. I'm just here to tell you that if you do add sulfur, you're going to get some antimicrobial effect as well as antioxidative effect and other benefits as well. So you be the judge. In doing some preparation for this presentation, I came across quite a few interesting statements. What I found most comical was this one here. Sulfur dioxide contributes significantly to hangovers. Heavy drinkers who also have to get up in the morning would be advised to stick to natural wine. So you be the judge. I'm not so sure of that statement, but there's a lot of statements out there about sulfur dioxide, but hopefully this presentation has cleared things up for you a little bit so that at least you're educated enough to make decisions for yourself about it now. So at this point, I will take any additional questions that you have for me.
Okay, we've got a bunch, and we're close to the end, but I'm happy to stay and keep doing questions if you're available for that, Demi. Are you? Do you have
Sure.
time?
Yeah.
Okay. And then if anybody has to leave, this is going to be recorded and I'll post it as soon as possible. So if you didn't hear your question, you had to leave, just check out the recording later. So a couple of people are asking about the Vinmetrica SO2 analyzer. They want to know what your opinions on it are. What's the accuracy? Do you know about that?
I am not particularly familiar with that one, but I would be happy to look into it and provide those people with my opinion after I'm able to educate myself about it.
Sounds good. Okay, Sean and Al. So yeah, email Demi if you want to follow up on that. Thanks for those questions. And then Bradley asked, could you please address auto titrators? There are several new ones on the market, but I think they're all still using the Ripper method. I don't know, is that too nebulous or do you know anything about that?
So the ones that I'm aware of, a lot of them, a lot of the auto titrators, especially the small benchtop units, they are using the Ripper method. I have experience with a couple different ones, but really they're all based on the same principle. They are not using a photometric reading of the color to determine the endpoint. What they are using is a pH probe. So that arguably is a more accurate method because your endpoint is going to be determined by a set pH value and not by someone looking at it going, yeah, that looks dark purple or that looks black.
Okay, perfect. Tony wants to know if you have any experience or insight for SO2 rates for sparkling base wine in storage.
That's a good question for sparkling wine. I would say the general rules still apply. So it's a white wine base, right? And you're going to remember that you're going to get a little bit of total SO2 as a product of that secondary fermentation. However, most of that total SO2 is going to go straight to bound SO2 and none of it's going to be free SO2. That said, right, why are we adding SO2 in the first place, right? Part of it is for its oxidation protection. If you're doing a secondary fermentation in the bottle, you're going to have some inherent oxidation protection based on the fact that you have yeast in there, there's a secondary fermentation going on, and you're getting carbon dioxide in the headspace. So generally, I would say that you need less SO2 for sparkling than you do for still wines.
Okay, great. Gwen wants to know, do we use the 0.5 to 0.8 SO2 molecular if we want MLF to happen, or is there another level for MLF? So I guess can you just reiterate the desirable levels for MLF?
Yes, so if you're planning on doing MLF, I would wait till after the MLF is complete to make any additional sulfur additions.
Sounds good. Sounds like what I used to do. Okay, Jeff wants to know, during the aging process, is it okay to add slightly higher amounts because the wine will probably sit for several months?
So that goes back to that graph that I showed at the end there. So if you're planning on cellaring your bottles for, let's say, 2 to 3 years before release, I would say that as long as you're not adding abundant amounts and it's not a red wine, right? Because you do want to be concerned with some bleaching effects. I would say that yes, generally you can add a little bit more sulfur if you know that you're going to be laying it down for a considerable number of years, or you know, if you're really, you know, shooting for you know, like those Bordeaux's or, you know, Burgundies that you're going to sell there for decades.
Great. And Dennis has a question that I also have and kind of want to extrapolate on. So he said, sweet wines like port, what SO2 levels? And my question is, when you're adding to a fortified wine, like how do you take into account the fortification?
Yes, right. So there's a kind of a conflicting war going on in the wine, so to speak. So your higher alcohol levels are going to serve as a protectant, especially against any kind of spoilage organisms. But at the same time, you have higher sugar levels. So there, I would, I hate to say it depends, right? Because no one likes that answer. In the case of a fortified wine that is extremely sweet, I think, you might be pushing those total SO2 levels. And in those cases, I think that it would be helpful not only to measure free SO2, but also be aware of total SO2, especially if you're dealing with something like a sweeter port that is high alcohol, but not necessarily really high alcohol. In terms of numbers, in free SO2, I think, you'd probably want significantly more. So total SO2, I think you're allowed up to, uh, you know, 300 or so in the EU, obviously 350 in the US and Canada, regardless of what the product is. But I think what you have to consider there is if you add too much, right? Even if it's a sweet fortified product, you're still going to get that sulfur off aroma and sulfur burn. So how much is too much and how little is too little for a wine like that? Um, I would say you still probably don't want to go above 40 to 40 ppm free SO2.
Okay, sounds good. And Dennis, please follow up with Demi if you want to pursue that more. So then we have a question from Tim. I think I can answer this as well, but he wants to know about the status of the new direct headspace gas measurements with the detection tubes. Are there commercial applications available? Do you want to speak to that, Demi?
I do know that there's current work being done on that. I'm not sure as to the success rate of that work at this point.
Yeah, last I spoke to Gavin about a week ago, he said they're still not, I don't think, commercially available, so they're very small scale. And I will post a link in the chat bar for you guys that links you to the protocol, and you can see like what they bought and how to put it together. But I don't think it's like a massive commercial scale level yet.
No, and I think too there are still some kinks that are being worked out, so to speak.
Cool. Okay. Chris wants to know if you're filtering a wine with high levels of residual sugar before bottling, should you increase the free SO2 level?
Yes.
Perfect.
I would generally say yes, that's not a bad idea. And make sure that you do give yourself enough time for the SO2 to, kind of dissolve and distribute throughout the wine before you put it through the filter.
Great. And let's end with this one. And where is it? Okay, John wants to know how long after SO2 addition at harvest should you wait to add the yeast to start the fermentation?
Again, so are you inoculating or is it going to be a wild fermentation?
I think it's inoculation.
It's inoculation,
yeah.
Right? So I would say, depending on how much you add, right? So it goes both ways. If you're planning on inoculating the next day, a very low dose, right? If you're getting a bunch of grapes in and you're not going to be able to get to it for a couple days, obviously a slightly higher dose is going to be better there. I mean, you'll know if it's too soon because you'll inoculate and nothing will happen.
Great. Okay, I think we've taken most of the questions, and like I said, feel free to email Demi if you have more specific questions. You can also forward them to her through me when you get your feedback email tomorrow, when we're going to ask you to please tell us how this webinar was. And with that, I'd like to thank everybody for joining us for the last Northern Grapes Project webinar for the spring. And we're so glad that you attended, and we hope it was useful to you. Please, please answer the feedback email. Let us know, not just for this webinar, but for the others if you attended, what you thought, what was useful, if there were to be another series, what you'd want to see. And with that, have a great day, everybody. Thank you so much. Thanks, Demi.
You're welcome.